modern method of construction makes a lot of sense. It's all about efficiency and speed on site.
These aren't new technologies, they are newly adopted technologies in Australia, and this is proven technology.
It helps you build more quickly, and time is money, and that's the advantage to builders, not have to worry about the scarcity of labour. The next boom, you won't be able to get carpenters, you won't be able to get brickies. We'll be building in our factory with the same crew and doing it really efficiently.
Hey folks, Rob Flux here with another Sunday session, and today we're continuing with our series on modern methods of construction and looking at yet another technology. Today we're looking at panelised constructions, and we've got a very special guest in order to go through that. We've got Sean Ralphsmith from DWTT to talk all about their methodology, their approach and that sort of thing. One of 4 different methodologies that we've been carrying on about in this last little series. But firstly, Sean, welcome aboard, mate.
Thanks, Rob. Great to be here.
Mate, firstly, let's talk a little bit about who is DWTT. You guys have been around for a long time, 40-odd years as I understand it. Where did DWTT come from and how did they move into this MMC space?
Sure. So DWTT is Druin West Timber Trust, based in Druin in Gippsland in Victoria, just outside of Melbourne, and started as a timber mill, 3rd generation Ward family. Peter Ward is the founder and owner of the business, and he developed a frame and truss business out of the timber mill in the early 2000s, and then ultimately closed the timber mill, built a new site, and was an expert in frame and truss, and then in the last 12 or 13 years has been developing the panelisation business within DWTT, which is called FutureFit.
Yeah, and we can see the things behind it. FutureFit being your own internal, I guess, branding and naming and that sort of thing, but it is basically trying to take that whole framing business and I guess add value, so that add value in the factory side of things, so that when the builder gets to site, there's actually less work to actually do from their side.
Well, that's true. So panelisation, we basically, just to get into the detail, we can stand up a double-storey townhouse shell in a panelisation form in 2 to 3 days, and we typically do 2 in a week. So it's really quick construction for the outside shell. And if we talk about panelisation, what we do, we're experts in frame and truss. We do frame, we do external cladding, we install windows, and we install on site. So give us a slab, and a week later you'll have a couple of shells of townhouses for all your other trades to follow us on, 4-bedroom, double-storey townhouses.
So it sounds amazing, Matt. And obviously the builder then has to do all the fit out of all of that and that sort of thing. But we're going to kind of get into all of that as we go. But the whole idea is speed on the ground, folks. And so now, as you said, 11 or 12 years that you've actually been doing this. So this is not new technology, and it's equally not new in Australia. It's just not very widely adopted, mate. What do you think is the reason for that?
Look, it's interesting. It's not well known in terms of our ability to do what we do. And in the last 6 or so months since I've been in the business, we've really been out doing a lot of business development, and haven't spoken to a builder yet in medium density that isn't really super interested in what we do. It's just that we've developed a relationship with 1 or 2 anchor clients. We get a lot of work with them and progress really quickly with them. And then we haven't really developed the knowledge out in the market, which we're just starting to do for other clients. So we have greater capacity now. We're adding to our factory, which we can talk about in due course, but therefore we have the ability to do a lot more. And a lot of businesses have actually tried to do this and started up, and some have failed because they built a whole factory and then couldn't make them come. Whereas we've started with a customer base and grown with some customers, and so we've built the capability and learnt along the way without feeling like we had to invest millions and millions and start from scratch like some businesses have.
Yeah. Well, having said that, I know that you've invested millions and millions, and we'll talk to that in a little while. Let's kind of leave them hanging on that one. But has evolved, I guess, with the industry and themselves maturing is probably the right way to actually frame that. But now, I guess the whole push for MMC and the different technologies that actually sit there, now people are starting to become a lot more receptive to, I guess, the kind of things that you guys are doing. Let's break down, I guess, what actually goes into a panelized system, because a lot of people are very familiar, a lot of builders in particular, they're very familiar with bringing the frame to site that's already been built. And that, I would say, in the last 10, maybe 15 odd years, has become a fairly popular way of doing it. So the actual chippy building on site still occurs, but I guess getting framing solutions, whether they be timber, whether they be steel, has become very, very popular, and they see the benefits of that. What's the value add that you guys do to take that frame and then add some extra value to it so that the builder's doing even less work again?
Yeah, so good question. I mean, prefab frames, as you say, walls and roof trusses have been around for a while. And in my previous role, I was running a volume builder, and we really started to invest in dealing with those sorts of businesses and suppliers to build more quickly. So it helps you build more quickly, and time is money. And so therefore that's the advantage to builders to get the job done. We add value by taking it several steps further, such that you have a building that's pretty much close to lock-up when we're finished after a week. And so therefore from an HIA contract perspective, you can get your frame and your lock-up claim within a week, when that would normally take 8 to 10 weeks.
And just for the builders out there who are looking at this, for most of your contracts, that's a 65% payment that hits the bank account very, very fast, folks. So cash flow suddenly becomes less of an issue from the builder's side. And we can talk a little bit about, I guess, the cash flow a little bit later on, but that's one of the first benefits. But the value add that you're actually adding, so to get it to lockup, there's a whole bunch of I'm going to loosely say things. Now, I know what the things are, but I want you to kind of flesh them out, that you need to add to the panel. So we've got things like the windows with the cladding, those sorts of things that you're actually going to add on, so that by the time you get there, it is effectively watertight. So how does that work in your factory? How do you actually do it, and what are the elements that you put together?
Yeah, so our factory is a frame and truss plant, and then a panelised line or two, plus now some robotics in our in the factory, which is quite a large footprint of 10,000 square metres out in Druin. So we'll have the wall frames that are produced. They'll go down our line. We now have a robot that can build put the frame, pick up the cladding, nail the cladding, cut it to size, lift it off and put it into a stillage that will be put on a truck for delivery. So what we will do is build the frame, put the cladding on, cut the cladding out to the specification of the design, take it down the line, nail it off. We'll put breather paper, whatever's required in terms of membranes, etc., that meet the specifications of building code, and then take it to the end of the line into our magazine rack, as we would say, lift it up. Magazine rack is where we can bring an automated machine to pick up the windows that have been delivered to our site, put the windows in and install them, seal them as they are watertight and to specification, and then they're lifted off, all ready to go and put on a truck. So we will then have a complete townhouse in a couple of truckloads that can be taken out to site. Once the slab is down, ready to go, our install team will meet the truck on site and stand those panels up, and we'll basically do a double-storey townhouse in 2 days.
So that's amazing. So far, we've talked about, I guess, the frame and the external side of things. But if we're talking double-storey, there's also a floor that needs to go in between. So a thing called a flooring cassette is how, I guess, yourselves approach that. Mate, what is a flooring cassette?
So a flooring cassette is it's the floor that comes. We build flooring cassettes in our factory in another line. So we'll build the long reach trusses out of timber. You might have heard of posies or I-joists. They're the alternative elements of a flooring cassette. We'll do it in timber because we're a timber business and we can do it efficiently. We'll put the trusses together, put the yellow tongue on top with a lifter, cut it automatically, nail it automatically in our lines, and then lift it up off and put it onto the truck. So we might have 4 flooring cassettes for a full townhouse that can be lifted up in a big square and placed on site. So you'll build the downstairs frame and then the external panels and then the flooring cassettes, and on top of that we'll put the upstairs internal wall frames and then the external panels and then the roof trusses, which is the last element of the build before you put the roof on. And so our shell will comprise all of that. So internal, external walls, panels and a roof truss. And then we will always coordinate with the following trade, which would be the first one to follow us once the scaffold is up, is the roof up. So once the roof and the front door is on, it's lock up. And with our current major clients, they'll have that done within a couple of days of us finishing. And so that's when they can get their lock-up claim.
Yeah, and it's important that the roofer does come in pretty much back to back, because otherwise everything is exposed to the elements and that sort of thing. So we want to, I guess, from a timing perspective, make sure that we've got a good weather window to install that, and then have the roofer back us in, and then, as you said, lock up in literally a couple of days. So now all of that is exciting on site. But before we even get to site, there's a whole bunch of things that have to happen well before we actually get there, because all of this, it doesn't really change the effort. It just changes the order of the effort and the thinking about how we've actually got to process all of this. Because we're not on site and trying to deal with variations on the fly, we need to think about all of the issues and challenges and implications and knock-on effects and that sort of thing at the planning stage. So it's a lot more planning heavy to think about everything, pre-order, what is the cladding, what is the I guess the windows that we're going to be doing and all that sort of thing, so that when you get to the production line, it's all systems go.
Yes. And as a rule, flat claddings work well in our factory. So things that can go down our line, panels that sit on top of frames and that the machines can go over the top of and cut and nail. So we're talking about James Hardy type products, Axon, Stria, etc. We use EBS, which is like a Masterwall product, which is a lightweight cladding foam, high density foam that has a finish on it that is ready to be rendered. So it just solid as a rock once it's been rendered. And the designs that are put together that work best with modern methods of construction and panelisation are those flat claddings and that sort of flat product that goes well in the factory and stands up really quickly on site.
Yeah, so which means that there's other things that don't necessarily work well with this, and that has to be added. The value has to be added on site. So so there's going to be things like, if you actually want to do, I guess, a brick facade, then you're going to put the frame in and the bricking comes afterwards. If you're going to do things like, if you want to have a rendered, I'm having a brain fade on the technology now. Help me out here. Aerated concrete.
Yep. Hebel.
Hebel, thank you. That's the word I was looking for. Not the only company out there, but that's probably one of the most popular ones. If you want to do something like a Hebel, that doesn't really suit the factory production line, but it can be added, I guess, in process. But that kind of thing, if you're looking at that creates some challenges for you, because if you're trying to use Hebel as your firewall between two townhouses, then you'll come in and stand something up. Then you have to wait for the Hebel guy to do his thing before you can then go stand the next one up. So does that cause challenges from time to time, mate?
Well, it does. I mean, that's not ideal, but it can be done. It can be accommodated. But the majority of our clients, if they're using a Hebel party, will look at, say, our ProBoard system, which is a fire block system that is the equivalent alternative in a zero lot where two townhouses are built right next to each other. Fire rated, approved under NCC, that can be done in the factory. So it's a simpler product when you are working in a factory, so that we don't have to wait for a third party to come and install the Hebel. So typically that could be substituted in a standard job. If you've got brickwork at the front, a facade, we can accommodate that where we just build the frame and the bricks can come later. Or there's lots of brick panelling out there now that look fantastic, and we're really starting to dabble in some of that product that can go down our lines and be nailed on our lines that will look the same. But if you want true brick, we can accommodate it at the front. But if you're going to have a majority downstairs brick, it doesn't lend itself to panelisation because it slows the process down and you lose a lot of the benefits from the factory manufacture and the quick install.
Yeah, so but the nuts and bolts of it is you can get the same look and feel by using substitute products and you went through it very, very fast, but basically a facade, for want of a better word, that actually has a thin layer of brick on it that's only this thick, that looks and feels the part, but is actually flat and hence suits the production line very, very easily. So there's going to be times where you may have already done a design and you'll come to an organisation like DWTT and they'll make suggestions to say, look, if you think of this alternative technology, it's going to work much better on the production line. But you can work with the other things, but it just introduces other things to think about.
Yeah, if you're flexible in your thinking and we can maintain the look and feel, because obviously design's important, it makes your product saleable, so we need to make sure that the product looks good, and what we build typically looks really good. So there are all of those alternatives, and one of those is, brick paneling that can, these days, there's lots of new products on the market that you'd swear are real brick, and they're not. And some of those can be used on our line. So we're really experimenting with those right now to
so
give that
for
option.
all of you people in Perth who love double brick, I want you to take note of that. So it can look and feel the same thing and nobody would even know the difference. Okay, so understanding that, there's obviously, I guess, some thinking that need to happen with regards to, okay, what products, what technology, what are we actually going to be using to actually put this together to streamline the service? That really comes, and we talked about it before, the design side of things and putting that together. Typically, what tends to happen in the real world is the architect does a design, the developer lodges that for a development application. Development application comes back, and then they go to the builder and go, right, can you build that? Right. Yeah. Whereas this is something that we really want to have engaged very, very early, where I guess the architect has an early engagement with yourselves, understands the technology, understands what can be done, how they can get the same look and feel using alternative technologies, and design for manufactured assembly, DFMA. I've been prattling on about this for a while, guys. Ask your architect to do DFMA and engage with whoever your technology provider is to say what are the opportunities and challenges in their systems. Would you say that's a fair assessment, mate?
Absolutely. So if you're working with the designer that understands what goes well down the manufacturing lines, then it makes life much simpler for everyone, removes complexity and gives you the best and simplest outcome. So we're often approached with by builders who've already got a plan or developers who've already got a plan. And so we can build what they've got, make recommendations on substitutions. Some are done really easily. Often the plans might say a product or equivalent, and so therefore it really doesn't need to go back to town planning or whatever when you make those sorts of substitutions. But if you get with the designer or the architect from the outset, then you don't need to make those substitutions, and it lends itself to a simpler process.
Yeah. So forward planning all of that up front, folks, is no matter what technology you're using. Obviously, here we're talking about panelized, but every single system has opportunities and challenges. Designing for that up front means that the streamlining of that service later on, I guess, then gets the true benefit of what you're actually trying to achieve.
Absolutely.
Now, once you've got a set of finalized plans, I guess there's still the engineering side. There's still the actual, you guys have to, I guess, digitally build it in your world so that you can actually put it through the production line. And there's, I guess, some processes that you need to do from a design perspective to actually do that. Give us some insights into what that looks like.
Yeah, so look, some of the best skilled people in our business is the design team that sits out upstairs in our factory, in our office. we've got many detailed designers and those that are experts in panelisation. So we use a Prida model for our frame and truss in terms of the detailed design, and there's a software called HSB CAD that takes those plans and then builds the panels around them to fit appropriately. So that's a pretty unique skill, people that are skilled in that software, and we've got some of the best in the country that work with us. And so we will take those plans and detail it such that when you send the electronic plan down to the factory, the machines just pick it up and they can cut it and nail it and build it automatically. So there's a lot of automation with that. And there's so much detail in the software that it'll also allow us to detail how we stack a truck for most efficient loading, such that we can get most of the panels on a couple of trucks, drop deck trucks that then can be delivered with a crane truck onto site and then lifted into place and installed. So it'll give you an efficient method of loading the truck and also the order in which it loads, such that the last one on is the first one off. And we're so well practiced at having done this 800 or 900 times in the number of townhouses that we've built in panelisation that we've got the process down pat.
Yeah, well, that's an interesting point to point out. There's no point panelising it and putting them in a random order on the truck, and then you're rifling through a list of panels to go, which one should I pull out next to actually stand this thing up? So the ordering and the sequencing of this is as critical a process as anything else.
That's true.
I guess the next thing to actually think about, I guess your design team actually has an engineering element to that as well. Now, traditionally, we might engage an engineer to do all the structural elements of that. I guess there's opportunities and challenges in us doing that on your behalf when that engineer doesn't necessarily understand your technology. But you have the in-house engineers to say, well, this is the amount of weight that we're actually going to be holding up. This is where the load needs to be. So you guys can then build, I guess the underlying frames and trusses and flooring cassettes to actually take that engineered load, knowing that you're going to be 2 stories or 3 stories or whatever that's going to be. Do you find can you work with external engineers, or is it better to keep it in-house?
Look, no, an external engineer will typically do the engineering drawings, and we'll take those drawings and make any adaptations that are required to ensure that they meet our system. Often there's not a lot of change required, but we typically will engineer out any steel that's unnecessary because we're a timber business, and we can often do that. So it removes costs, but also therefore becomes more efficient for everyone. And the Prida software and the HSB CAD software builds to engineering specifications. So it will tell you whether or not it's engineering is sound, and we will always make those adaptations in line with that. And then, like I say, it then produces a file that can go down to the factory and be effectively built.
Yeah, so it can be done either way, but my lay assessment as an outsider and not being inside your business would be, I guess, if it was done in-house, then you're doing the 2 of those things at the same time very efficiently and very effectively, as opposed to interpreting someone else's work and trying to, I guess, comply with that. Because you're going to see opportunities, I'm guessing, where over-engineering can occur from time to time, and equally not thinking about, and like you said, steel, so not thinking about, hey, if we do this in a timber frame, how do we do this and engineer that out?
Yeah.
So thinking about that right up front. So where possible, I would highly recommend using the in-house engineers to actually get that done. And you might just use your external engineer for, I guess, the slab and the footings and that sort of thing. And the 2 of those have then got an interface that's very clean to actually know where the handoff points are.
Yeah, look, we'll always work with an external architect or the builder's architect and an engineer, and then make the adaptations to meet the panelised system. So we're not building our own designs. I just want to make that clear. We're working with other people's designs. But if we talk to the designer and the architect from the outset, you get the best result.
Yeah. Now, obviously, all of that, I guess, design and engineering elements, there's, I guess, a I guess, a cost to every single project that actually does that. But if you're able to patternize this product and you go, right, this floor plan that I'm actually doing, the next time I do another project, if I can use the exact same design, pretty much all of that engineering and all of that pre-work has already been catered for. So this is, I'll say, a one-off cost if you can actually do repetition of design.
That's true. So with some of our anchor clients, we'll have 2 or 3 or 4 of their designs that we've designed before and built before. So then as they come through for the next stage of a development, say, and we've done 80 or 90% of what they're building and they've made some adaptation to the facade or the back or whatever, just for a bit of streetscape change, it makes it pretty simple for us to go through the process, make those tweaks, and then take it down the line to build again. So yeah, we're always dealing with new customers that have new designs, but for those customers we've done a lot of projects with, then it's a much quicker process because we're very familiar with their designs and the 3 or 4 that we've built many times.
Yeah. So I guess message for my audience who might only do one project every 12 months or so, and maybe it's a small, only a duplex or something like that. Start to pull together, get 5 or 6 of you together and go, right, can we come up with the exact same design, get some, share the costs between all of you, have a pattern that you can actually, I guess, apply at different parts of, I guess, the city, different parts of the country, where nobody's going to tell that that's the exact same product. You might change the facade to make it different. You might change the internal fit out, high finishings, low finishings. We're just talking about the shell here, guys. If we can get that, we're going to get very, very cost effective actually doing that. So building patterns and working together to actually come up with those patterns is one of the, I guess, the smart ways to deal with this efficiently and effectively. Otherwise, that front end cost has to be borne every single time. But this, I guess, brings that cost down. Everyone's worried about cost to construct. That's a tip, folks. Do that.
Yeah, I agree. And so repetition in modern methods of construction makes a lot of sense. It's all about efficiency and speed on site, but also speed in the factory to get the product built. Absolutely.
Yeah. So now let's go into the actual timelines and actually putting this together. Once a design has come to you from an architect or a developer, whether it be DA approved or otherwise, what is the timeline for that internal review and I guess recrafting of that design to actually convert that into a panelized system? How long does that typically take?
So if we've got the go ahead and we've got the plans and we've agreed how it looks, maybe any substitutions, it'd probably 2 or 3 weeks for the internal design, for a detailed design. Then we'd be ready to put it down the lines and start building the panels. And the rate limiting step always in this process is the windows. So you need to coordinate, because when you build in a stick build fashion or a traditional fashion on site, you build the frame, you get the cladding, and at some stage down the track, you'd get the windows, and they'd be installed after a lot of that work has been done. Whereas the windows need to be delivered to our factory. And so that when the panels go down the line, we pull the windows off the stillage to the back, they get installed, and then they're loaded into a stillage to go on the truck. So the rate limiting step is the window delivery to our factory. And that would then, we'd be building one townhouse a day down our lines, 1 or 2 a day. And so therefore we'd need the windows in time to make sure the sequencing works well.
So which then brings us to the next little element. If you are doing a custom sized window every single time, then that delay is waiting for that window manufacturer to build that custom window to actually deliver. Whereas if you're starting to use standardized sizing, then chances are they've got a dozen of these sitting on the shelf already been made that they can actually just pick up off the shelf and deliver. So you massively improve your timelines. Standardizing on your kit of parts that actually goes into these things, and using as much as we can industry standard sizings is going to make your world so much easier. Plus that manufacturer now, knowing that they're going to do lots of those standards, they're going to get more efficient, more effective at just doing that. So you're going to find the cost of those standard ones start to come down as everyone starts to standardize. It drives me nuts that how many times I see a custom window or a custom, sized opening for a sliding glass doors and things like that, just doesn't need to be there. It's adding cost and complexity and timelines that if we just shaved 30 centimeters off in some instances, you could just get it off the shelf.
No, that's true. So obviously window manufacturers love that as well. But even if you do have some element of customization, it's about the timing. When you have a set of plans and engineering plans, you'll also have a window schedule, you have a slab plan, etc. The window schedule, you just need to have your builder be aware that the timing of the window order needs to be sooner than it would be in a traditional build compared to a traditional build.
And typically, what are you finding that lead time is? If they're using some standardized sizes, what is typically that lead time that you're finding?
So we use, 2 or 3 of the major window manufacturers. A&L Windows are ones that even stack the windows in the right order for us to put them into our frames that we work with them so much. Their lead time would be anything from 2 to 5 weeks. 2 weeks would be probably more standard product, and 4 or 5 weeks, depending on how busy they are, would be where they actually build, customise their windows. I think a majority of their windows are still custom built, despite having some of those major products like sliding doors off the shelf. So you get the order in with them, that we know that their window order, they'll give us a date. It might be 3 weeks down the track, and we'll be building the panels and hanging them up at our magazine rack, which sounds interesting if you haven't seen it, waiting for the windows to be installed. So we need to get the timing right, otherwise our process stops with panels at the end of our line waiting for windows. So it really is quite important that the timing's right, but we'll work with the window manufacturer to know when they're going to deliver. They love delivering to our factory because they drop 2 major cylinders off at the back of our factory ready for us to install, as opposed to finding a site out in the suburb somewhere, having someone there to receive them, asking where to put them, and then on site remembering people have to lift these windows up and carry them through a busy, dirty site, and sometimes upstairs or whatever, to install them on site, compared to the windows arriving on site in the panels and being stood up, already in place, already watertight, already meeting specification. That's one of the beauties of panelisation.
Yeah, and so just the efficiency of the build. I've touched on this a couple of times, folks, but it's worthy of repetition. The same work happens in the field as it does in a factory, but in a factory, it's controlled environments, and because it's a controlled environment, the accuracy can be much higher. You haven't got people in the elements, so they're not, not able to work because it's raining, and they're not able to work because the sun is beating down too hard. But it's the efficiency of the flow. They're not spending 45 minutes unloading their toolbox and then reloading that at the end of the day. Those sorts of things start to come into play. So the same person that's doing the same amount of work in a factory means that they're more efficient at actually doing it. So the throughput is higher, but also the accuracy and quality control is much higher, which is super important. And then you add, I guess now what you guys have done is actually add some automation and robotics into the system. And now some of the pure manual labor side of things is now able to be sped up and be even, whilst it was millimeter accurate before, now we know it's millimeter accurate because it's all precision measured. And watching that machine, it's like watching a choreography, mate.
Yeah. Look, 2 millimeter tolerances. You can set the tolerances with the robot, but yeah, 2 millimeter tolerances. So you don't get that on site, but you've got to get it right up front, because once you get on site, it's much harder to make those changes. So absolutely. And so the efficiency that comes with all of that is really important. And it's worth mentioning that in Europe, because of the weather in Europe and deep winters, that 50-60% of homes are built in factories. And we don't have any down days because of weather in our factory, because we've got a roof. And so we're really a fair way behind in Australia relative to other countries and other parts of the world, and that's born out of necessity because there's so many days where they can't work on site in Europe, so they have to build off-site. And we're just driving those efficiencies that come from building in the factory, and also the fact that labour is getting harder and harder, and skilled labour is getting harder and harder to come across on site. And so therefore we can build to those specifications in our factory and not have to worry about the scarcity of labour. When we go through the next boom, you won't be able to get carpenters, you won't be able to get brickies, you won't be able to get these labourers that can do a lot of this work. We'll be building in our factory with the same crew and doing it really efficiently.
Yeah, well, I think the demand for the next boom is here already. So that it just needs, I guess, a lot more builders to take on all of these MMC type approaches to say, well, what is the right fit for the right project? And this is clearly one of those that is a perfect fit in a lot of instances. So when we start to put all of that actually, there was one point that you did say Europe is like at 50-odd%. The global leader in that is Sweden, I believe, that is about 80% of prefabrication.
Further north you get, the less work days you've got on site, right?
Well, until you get far enough north where the sun is just shining 24 hours a day, and then you're not limited. But I guess the weather has huge impacts there. So I guess prefabrication is very very much ingrained in that, and has been for quite a long time in Europe. So and it's just Australia trying to catch up to this. So these aren't new technologies, folks. They are I guess newly adopted technologies in Australia, and that's the key thing that I want everyone to understand, that this is proven technology. So
that's true. It's probably why a lot of our machines come from Europe, Rob.
Yeah. Now we've kind of touched on all the timelines, I guess, individually through the whole show, but let's kind of pack all of that together. So we get a DA, then we come to yourselves 2 to 3 weeks to, I guess, find alternative products, re-engineer that, actually come up with a design. If we've got standardized windows, it might be a 2-week lead time. If we've got non-standard, it might be 5. Then you said a townhouse, 1 townhouse per day coming off your production line. So, if you're doing a 6-pack, that's 6 days worth of that sitting there. Take that to site. I think you said 2 days per townhouse to stand up. So we could be sequencing that 6-pack, let's just say 6 or 7 days.
So if we often build banks of 6, 8 or 10. So if we're building 10, townhouses for a developer, we'd do a week for each pair of townhouses. So we'd do first townhouse downstairs over the first 2 days and 4 days for the second upstairs trusses, and the 5th day quality control. That's when the builder will get the frame inspection. And then if they don't have the roofer on site the following Monday with the scaffold up, then they're losing time. So we would do 2 per week. So it'll be 4 weeks to build 8 and 5 weeks to build 10 from our perspective. And typically, and there is a video that shows a time lapse of one of our projects, that you will see that what will follow us is scaffold. So if we're building 8 or 10 in a row, after we've built the first 2 and we'll get to the next 2, the scaffold will go up fairly quickly on the first 2, and the renderers will come in, the roofers will come in, the front door will go on. So the roof goes on soon after we're finished, and that's lock up. And then the renderers are next up on the scaffold to start the finishing on the outside. And then all the trades come in on the inside. So
we're 2 to 3 days to lock up. So we're massively compressed this in. You mentioned the video. We're actually doing an overlay of that. So you're going to see, in this instance, it was a 10 townhouse project, and the 10 townhouse project was 22 days for the elements that were DWTT. So there was firstly some site prep that needed to happen. So all your sewer and stormwater and your foundations and your slab and all that sort of stuff. But once you've got that, that's typically about 4 weeks to get to that point, maybe 6, depending upon if you've got a complicated site or a number of things to build. Then DWTT were on site for 22 days. And then the builder was then able to come in and do the fixtures and fittings and finish the internal finish of that a total of 52 days from start to finish, from slab to handing the keys over to the other owner.
So from slab to for lease sign, going up, you can see it on the video after day 48 or 49 out of the 52 days. And so it really is about sequencing. So we start the momentum on the job. We get the momentum going, and you need to work with your builder to ensure that their management of trades follow on fairly quickly. And that is, many builders are disorganised, not all builders, that would be an insult. But if you've got a builder that's organised, they will have the sequencing of the trades to follow us, and all the internal trades and the finishing carpenters, and then the installation of cabinetry and electricals and plumbing, etc. And plaster will follow us, but follow us soon afterwards, because we'll be there, we'll be up, and then we'll be out of the way.
Yeah, I'll give the builders a little bit of a break here, mate, and it's probably more a factor of traditional design requires because it's a much slower process. As a trade needs to come in, they can't complete what they need to do. So they have to come and go and come and go and come and go over many, many times. So often the builder is waiting for that tradie to be available to come back because they're doing another project. So rather than saying they're disorganized, I think it's a function of the old way of doing it, doesn't lead to efficiencies. But the new way, like you said, you've built the momentum. Now the tradie can come in, and he's now got a series of projects to do in a row. So he can move from unit 1 to unit 2 to unit 3 to unit 4, not need to leave site. So you've got all that savings of time where he's driving to the next site and waiting for him to finish that project. All of that then starts to come into play. And they might do a rough-in on one sweep. So the Sparky might do his rough-in, and as he goes from unit 1 to unit 2, then the plumber's doing his rough-in, and he goes from unit 1 to unit 2. And by the time they get to the end, the plasterers come in and done their thing. Then they can actually come out and do the fit-off again in that same sweep. And that's where the true efficiencies start to come in, that sequencing of trades and the project management side of that. Now, it's better for the builder. It's better for the tradie because he's not coming and going all the time. It's better for the developer. It massively compresses the timeline. It doesn't really change the cost per se, except maybe the tradie doesn't factor in as much travel time going in and out. But functionally, the efficiency is the time, and we saw it on that particular project. That builder has done this enough times that they understand that sequencing really well, and they've got their trades dialed in to know exactly how to do that.
Yes, so they've done it before, they've done it many times, and so therefore that building rhythm just kicks off and makes the whole project run swimmingly. So yeah, absolutely. You're right when I say some builders are disorganised. Whilst I'll defend that some of them are, it really is a challenge to get trades that are working on lots of other jobs. So if you're building 2 or 4 or 6, then it's attractive work for these trades because of the travel time, because there's more work in one spot so that they can get more work done in a short amount of time. And so therefore it is an efficiency for all the other trades as well, who follow on from the fact that the shell of the house has gone up in less than a week.
Yeah. Now that example is obviously that's a builder that's done it many, many times. They've dialed in their processes, that sort of thing. But for a builder that's doing this the very first time, I guess, what's the learning phase that needs to come in here? They're clearly not going to be that fast first go, but what's the learning phase? What do they need to understand about your technology, about how that system works? What are the things they need to consider in that?
So one of the really important things is the slab plan. So we'll do a slab plan with dimensions that are really quite specific because the panels need to fit maybe some overhang over the slab in some parts. So it can't be loose. It can't be 10 mil out, 20 mil out, 30 mil out front and back, or roughly edged. So often we'll, and it needs to be flat because the frames are going down, whether it be frame and truss or panelised. So we'll work with the concreter to make sure that, and the builder to make sure they've got the slab plan and it's built to specification. Then our install team will come out and flick out the lines, which is terminology for marking it out for when you preparing to stand the frame up and the panels. And at that point, when they do a slab inspection, they'll work with the concreter to maybe shave off edges or whatever that where it's not perfect, just so that we can make sure the panels fit. So a builder may not be used to that element of the job where we come out and walk around the slab and talk about what needs to be adjusted. And then the fact that we will then be so quick and programmatic and we'll tell them when we're going to be there, because it's booked in for the factory, it's booked in for the truck, and the our installer will meet the truck, and the crane operator is a costly element. He's part of the team, so he's going to operate the crane, and we're going to do it on the day we say we're going to do it. So that is what many builders may not be used to, but once they understand that and they work with that, then they can be confident in calling up their other trades to say, DWTT are going to be on site on Monday. They'll have 2 up by Thursday. We'll do a frame inspection on Friday. I need you there the following Monday to do the roof, and the scaffold's going up, and the renderers can be called up as well.
Yeah, and so you touched on it here. You've got an installation team that you guys go and actually stand all of this up, I guess, yourselves. So from a builder's perspective, they feel confident that that's actually there. Is it something that if the builder wants to take that on themselves, is that something that you're willing to, I guess, engage them in to go, hey, we'll help you through that process? Or do you find that adds complexity to the process and, I guess, doesn't add any efficiency for the build?
No, ours is a complete supply and install offer and price, and our site supervisors and installation leader have done so many of them that you won't get the efficiency unless you've got, exactly what you're doing and how they fit together. So that is key. Our guys are often in the factory understanding how they fit together and those sorts of things. So it is an install offer, and that's how it works best. And once the site supervisor's comfortable with that, they're happy, because they're knowing that we're responsible for the frame inspection, we're responsible for that stage of the build, and they just need to manage the ongoing trades.
And I guess the opportunity to come in and actually inspect the frames, both from I guess different terminologies around the country. So in some states it's a building certifier, in some states it's a building surveyor, and even the supervisor themselves to come in and go, hey, am I comfortable that this is actually built to a quality? That is all, you guys are pretty open book with that stuff. And I guess the surveyors, you guys call them, everyone else calls them certifiers, come in, inspect everything, sign that off. And so, you're individually tracking from a digital perspective. This is the design, this is the frame, this is how it was actually built, this is the panel. So it's almost like you've got a handbook on how each individual panel is made.
That's true. And the other thing we do is that we always, there's 4 or 5 building surveyors or certifying companies that inspect our frames and projects. We bring them through the factory, because there are elements of the build that happen in the factory that they can't inspect on site when the cladding's already on the frame and the fixings, etc. So they need comfort that we're doing it in line with specification, in line with the plans, which they can inspect, and the nailings at certain centres and sequences, etc. And once they see the machines do it in line with the plan, and they get a lot of confidence with the precision and the accuracy, then they just get so much more comfort on site when they're approving, because they know that it's been built in the factory and it's been done. And then it's just the external elements about how it's been fixed to the frame and the internal pieces that they can visually inspect around, fixings of the trusses to the frame up the top, etc., that they get comfortable with. So it's a simpler process once they understand that they've been through our factory and seen it built.
Yeah. So once we get to it being on site and at lockup, we've touched on this before, builder gets 65% of his payment at that point in time. Then their responsibility now is the internal fit off. So that is all your fixtures, all the fittings, all those sorts of things. So put in all your cabinetry and I guess, your kitchens and your toilets and bathrooms and that sort of stuff. So there's still quite a bit of work for the builder to actually build. So whilst we're streamlining a lot, there's still a lot for the builder to actually do. That's probably one of the things that I've seen builders concerned at, is to go, hey, I'm not building anymore. But there's still a heck of a lot for their process to do. But it's the efficiency of that really comes in, where some of those elements themselves might be. So for the cabinetry, for example, and the plasterboards upstairs and that sort of thing, how do they work with your team to go, well, I don't want to carry 1,000 sheets of plaster up to the second floor. Can they work with your team while the cranes are there on site and that sort of thing, and kind of coordinate at the same time?
Look, when we work with a builder, we often discuss those sorts of things. And one of the things that, as you mentioned, plasterboard getting upstairs is very, very heavy. So occasionally we've allowed for a window to be removed such that a crane could drop a load of plasterboard upstairs to the upstairs section of the house, and then the window be refitted. That would be one example of how we would accommodate with the other trades. But typically, other than that, there's only a few things like that. Whereas once we're finished, we'll leave it to the builder to coordinate the follow-on trades, because best that we get out of the way. But we stand by the frame inspection, and we're leaving to the builder to move on to finish the build.
Yeah. And speaking of which, you are clearly using a crane, so there are going to be some sites where you need to do some preparation work to actually understand, can we actually get crane access? What would be the order that we're actually building? Sometimes you start at one end and go to the other. You might be backing your way out of the project as opposed to building your way into it in order to make sure that everything loads right. What kind of considerations do you need to think about for that?
Yeah, it's a good point, Rob, and there's different designs of townhouses and projects that might be a bank of 8 at the back and then 6 at the front, and you think about overhead power lines, access to the site. So, we'd be on Google Maps from the moment we see an address and have a look at it, and then if we've got concerns, we'd get around there, and our team would visit the site and try and understand how the access is going to work, and then what the sequence of the build would make sense for us, such that it's easy to bring the truck and the crane to install them in the right order. So that would be another element that a traditional build wouldn't need to consider. And so we'd be working with the project team and the builder from the outset to say, hey, this sequence would work, and we'll need access along the left-hand side of the project for the majority of the project to get the truck in and out because of the power lines, etc. But other times, we're working in greenfield sites and it's not even an issue because it's all open and we can get front and back. But when we're doing infill sites within, knockdown rebuild and those sorts of other developments, they're just some of the considerations we need to consider early days to make sure that we don't set ourselves up for a major challenge.
Yeah. And look, given that you are, I guess, Melbourne-based and you guys do the install yourselves, does that mean that you're predominantly, I guess, the greater Melbourne area, or can you, this is a national audience, mate. I'm sure you're going to get phone calls come Monday to go, hey, can I do this in far north Queensland or something like that? Like, how far do you stretch your business to actually, how far do you reach?
Look, we have delivered and installed in Sydney, but it's probably in New South Wales, but we are pretty much Victorian-based. The trucks get on the road early, so we can do all over Melbourne, regional Melbourne, northwest, southeast, etc., and semi-regional. So it's pretty much a Victorian-based business. There's a couple of other players in other states that do what we do, but from a Victorian perspective, we're the leader, and we get the job done.
Yeah. Well, so for anyone who's based anywhere else, I'm sure that you would entertain having a conversation, but there's going to be similar companies out there doing similar things in your local area. So I guess what we're really looking at is the technology here. Obviously, FutureFit is one of the leaders in Melbourne and part of the Prefab Oz community. So I guess I don't know if there's an official endorsement on those sorts of things, but I guess give them a plug. But I guess we've done a fairly good wrap up here, Sean. Is there anything that I've not covered that you would like to go, you guys need to consider this if you're looking at this kind of approach?
Look, we've covered a lot, Rob, and I think most of it has been included. All I would say is that some of the products that we produce are state of the art. They look amazing, and you would never know that they've been built in a panelised form. And when you think about it, that makes sense because it's the same product. It's timber, it's cladding, it's nails, it's concrete, and it's windows installed. Everything's sealed, everything's done, whether it's done in the factory or done on site. These are really solid products that we produce, and we rarely have any issues. So there's sometimes people might think that it's, maybe a less solid product because it's being stood up on site. That's not the case. These are fantastic products, and because they're built specifically precision-wise in a factory, they're better than most builds out there, in our humble opinion.
And I would concur to say anytime you can actually control the environment that something is actually built in, innately, that brings benefits that are going to give you a better quality control product. And that's not a disservice to builders doing it out in the field, but there are just things like the elements and variables that happen on site that are, I guess, eliminated by doing it inside of a factory. So, I concur with that statement, mate. So, Sean, it's been an absolute pleasure, mate. I guess I'm going to wrap up by just going, if you're considering any form of modern methods of construction, and specifically the panelised type approach, it is super critical. You engage with your architect up front and you ask for 4 letters, DFMA, Design for Manufactured Assembly. If you understand the technology you're wanting to use, get that architect to engage with that provider and understand the opportunities and the challenges that come with that particular technology so they can design for that in the first place. You do that early engagement, and I think your life is going to be very, very easy. And the ability to do, as we touched on before, Sean, repetition. So one lot of design and one lot of engineering and that sort of thing, and then cookie cutter that design as much as we can, and working together. They would be probably the tips and tricks that I would add. Anything that you would give them as a passing tip and trick, mate?
Just get on the website, dwtt.com.au, and see how it's all done, or see us on LinkedIn.
Thank you, mate. So, folks, that's been Sean from DWTT talking about their FutureFit technology. So, been an amazing chat. One of the many in this particular series. If this is the first one you've caught, go back and actually look at some of the others. But not only do we run these YouTube channels, folks, but we also run face-to-face meetups all the way around the country. We run 55 events per year. Brisbane, Sydney, Melbourne, Adelaide, and Perth. They are also live streamed. So if you are in Brisbane and wanting to watch the Perth event, or in Melbourne wanting to watch the Sydney event, you can actually do that as well at the exact same time. We always have industry experts. We also have members of our community sharing real deals. So very, very worthwhile. Click on the link below in order to get there. Sean, been an absolute pleasure, mate. Thank you very much for your time. And folks, we'll see you all next time. Bye for now.